Okay, right, we're going to be doing an introduction to 3D vectors. We'll look at notation and position vectors, and all the while we'll be comparing them to 2D vectors, what we're used to. Okay, so vectors in 3D is what we're going to do. Okay, so first of all, let's have a quick look at notation. What I'm going to do is I'm going to split my page in half, and I'm going to show you it in 2D and then how it relates in 3D. There's really not a lot different. It's just adding an extra dimension. Okay, so we'll have 2D on this side and 3D on this side. Okay, so notation for vectors in 2 dimensions. There's a few different ways you can write it. First of all, and the way you've probably been seeing it often, is something like this. So how to get from one point A to another point B. These 2 points will be on a surface, they'll be on a flat plane. That's how you usually see it. You can, instead of writing it as defined as a direction between 2 points, you can write it as a vector like that. Remember to underline it, and it will be written bold if it's typed out. As we can't type it out, we underline it. Okay, so then the 2 ways you would normally see this written numerically, let's say that this vector is called A as well. The first one is a column vector. Let's have it going, I don't know, 3 that way and 4 that way. Okay, so we have our kind of horizontal component and our vertical component. So here we'd say this is going 3 to the right and 4 up. Remember, it's fine for there to be negatives. If that was a negative, that would be going to the left. If that was negative, it'd be going down. Okay, and then the other way of writing this, instead of a column vector, is as a unit vector. Okay, so we could also write that as 3i plus 4j. Okay, these mean the same thing, they're just a different way of writing it. Now we could, as the same as this, if this was negative, instead of being an add, if we were to have minus 4 here, it would be subtract 4j. Right then, so now let's compare this to 3 dimensions, and it's only going to change in a few ways. Firstly, if we write it like this, it's still describing how you get from one point to another. Okay, so from one point A to another point B, but instead of being on a flat surface, they're kind of within a space. Okay, so one could be up off the paper, one could be down off the paper. For that purpose, it's quite difficult to draw, and I'll do a sketch later to help us out. So yeah, you could still write it between 2 points. Just bear in mind this is not necessarily just on a flat surface. It could be above or below that as we enter the 3rd dimension. And again, we can just write it as a vector between 2 points. Right, now, this is where it's going to look slightly different when we have a column vector, and I think it will change in exactly the way you'd expect. This time, instead of just having a right and left, up and down, you're going to have like a back and forwards, okay? So let's say we're doing, let's have minus 3, 5 and 2. Okay, so these are your numbers to describe your direction. So this would be, let's say, going 3. We've said that this was going to the right, so this would be 3 to the left. This would like be going 5 up. And then you can think of this as being like 2 forwards. Okay, so it's in the other direction. So this one's kind of going up and down, this one's going left and right, and this one's coming up towards you and back into the page. Okay, yeah, so that's the only difference in terms of column vector. We kind of add this extra dimension where it's going backwards and forwards. You can relate it to coordinates as well. If this was to be going x across and y up, then this is like going x across, y up, and z forwards. Writing this is another one as a column, as a unit vector. It would be, let's do this one exactly as it is. So it'd be negative 3 lots of I plus 5j plus 2k. You just keep going down on the alphabet. Right then. So that's in terms of notation how things change. We just add an extra dimension here, like our z direction, and we have a extra unit vector k. Right then. Let's have a look at position vectors next. Okay, so a quick recap of position vectors. Position vectors describe how you get from the origin to a point. Okay, from an origin to a point. So let's say P has a position vector. Let's use what we did up there, 3, 4. And let's say Q has a position vector -2, 5. Okay, so as their position vectors, they're describing how to get from 0, or from 0, 0, the origin, to that point. So if we could do a quick sketch, if we have the origin being here, to get to P from the origin, you're going to go 3 to the right and 4 up. So it'd be somewhere like here. And that would be a straight line going there. And our vector from O to P is 3, 4. Right, next up, let's have a look at Q. So we're going to go 2 to the left and 5 up. So it's going to be slightly higher than that and going in this direction. So 2 to the left, maybe somewhere like that. And that would be Q up here. Okay, so that means from O to Q is -2, 5. Right, now a question like this is likely to ask, well, I've given you 2 position vectors. How do you get from P to Q? So ask you to find PQ. Okay, so we want to go from P to Q. Right, so the vector we're working out is, I'll add a straight line in here, why not? Is this one here. Okay, now we don't have information about that, but if you remember from vectors you've done before, we can use these lines to get from our starting point to our destination, okay? So we can work out PQ by going back down OP. So instead of going from O to P, you need to go to P to O. And then we can add on this vector where we're going up to Q, so plus OQ. Right, so we know what OQ is. We've written it here. So OQ we could write as -2, 5. And OP we know, but we don't know PO. Now, if you remember, if you want to go down a vector in the opposite direction, you just times this whole thing by -1. So that would be -3, -4 as a vector. Okay, obviously that is going to be -3, -4. The reason I put it in brackets is just in case you end up with 2 negatives, to remember to multiply them out to become positive. Then we just work these out by adding them together. So we've got -3 plus -2. And we've got -4 plus 5. Okay, so that gives us our vector from P to Q. So let's have a quick look at what's gone on here and compare it to our diagram. It's quite nice, we can, on a 2D plane, we can compare. So we're expecting to get from P to Q, we're going backwards quite a bit and up a bit. Well, we're going backwards, well, backwards being left, we're going left quite a bit and we're going up a bit. It looks like it roughly could be right. So I'll be happy with that if I was to answer an exam. Now let's have a look at 3 dimensions. So 3 dimensions, let's have, we'll still use P and Q. Let's say P is, I don't know, 3, 4, 1. That's its position vector, and Q is -2, 5, 6. And we're going to find PQ. Let's do the same as that one. Okay, now drawing this, it is possible, but it would get messy and you'd have to kind of, because we can't physically draw something that's coming up off the page, it will look a bit messy and a bit of a problem. So what we're going to do is we're going to go straight to the maths here. We're going to say, well, we're looking to find PQ. And I know that these position vectors are going to be, you could think of this as like OP, and you can think of this as like OQ. Okay, still the same. It's just that these points are not going to be on a flat surface. They're going to be kind of, well, this one's going to be 6 high and this one's going to be 1 high. So it's going to be an upwards lift as well. Or towards you should think of it as. Right then, so we know this is going to be, we'll do a little 2D sketch, why not? Let's say O. P, it doesn't really matter where these are. I'm just doing this so I know what to take away and what to add. So let's say it's something like that. It's not going to look anything like this, but I've got some value of P, and I know that I want to go from P to Q. So that means this, OP, I'm going backwards towards the origin. So I've got to take the negative of all of this. So we look at P, O, so that's from P back to the origin. So we take the negative of everything here, which is just like what we did before. I'm putting brackets around it to make sure I remember to multiply it out if I have to. Okay, so that's got me from there, from wherever this point is for P to the origin. Now I need to come back out the origin to Q. So that is following this arrow in the direction we'd expect. So I'm just going to add this onto that. So I'm going to go down OQ. OQ is negative 2, 5, 6. And that will give us our value of PQ. So now we've just got to do some adding. So we've got negative 3, negative 4, negative 1. And we've got negative 2, 5, and 6. And we have to add these two vectors. Negative 3 add negative 2 would give us negative 5. Negative 4 add 5 would give us 1. Negative 1 add 6 would give us 5. So this tells us that to get the vector PQ is going, you can think of it as 5. So it's negative 5, so it's going to be 5 to the left, 1 up, and 5 towards you.